So hi guys, let's continue with the last video on non-competitive inhibition. So let's just define, according to these equilibrium reactions, two constants. So Km prime, which we will just define as K minus 1 over K1, and Ki, which is specific for the inhibitor. Okay, so it's specific for the inhibitor, so that's to do with the K3. So we will have K minus 3 over K3. So these are the dissociation constants in a sense, because it talks about dissociation. The forward one's the dissociation, the backward one is the combination or the formation of the enzyme substrate complex. Okay, so now we have a situation where we have a lot of equations, so we need to start clearing up the mess. Okay, so what mess do we actually need to clear up? Basically, we'll need ES. We want to find out what ES is, so we have to make this the subject. Okay, so to make this the subject, we'll need to do some rearranging of these equations. So let's begin with the species E. This species. Okay, so beginning with the species E, we find that E lies here and E lies here as well. So it depends on which one you want. I think I'm going by guess that this is easier because there's no more ES in that equation and you want ES to be your subject. So I'm just going to go with this first. So let's put it. Ki equals to K minus 3 over K3 equals to E times I over EI. So let's write that down here. Ki equals to E times I over E and I. So this I can substitute here. So E equals to, in this case, Ki, EI divided by I. EI divided by I. So I can substitute this here. So let's just do that. E naught equals to E, which I substitute as Ki over, oh sorry, I didn't notice that, EI over I, that's the first term E, plus this EI term, plus ES, plus the last one, which is ESI. So now we'll have two more terms to get rid of, this EI term and this ESI term. So what can we do? We can get rid of the ESI term first. So from our earlier equations, namely this one, I can write K1 or K minus 1 into ESI equals K1 EI and multiply by S. And so this over this will give me Km prime, and that will be ESI, and that will become, that's just the product of EI and S. So effectively I can get rid of ESI and I'm left with this. So I'm just going to plug this in and we will get something like this. So I have Ki over I times EI plus EI plus ES plus EI times S over Km prime. So I'm just going to write EI times S over Km prime. Now it's almost perfect. Well, not exactly perfect, but we'll have this EI which we want to get rid of. So let's just factorize EI out, and we'll have Ki over concentration of I plus 1 plus, well, this S, concentration of S over Km prime, and U plus A, U plus ES into that. So now we are down to this term, which we'll need to get rid of. So is there any equation connecting these two? So I want this in terms of this. So let's take a look. Let's take a look back at our equation. We have this equation connecting the EI to E, and this equation connecting E to ES. So it appears that maybe, well, the thing is that maybe I made a little inefficient move earlier back then, because I'll have to use like 2 steps to convert this into an ES term. So we'll still have to do that anyway, but no matter, let's carry on with that. So let's have EI into K minus 3 equals to K3 E and I, K3 into E and into I. No problem there. So let's bring this to the bottom, and we'll have EI. And that will be E and into I over, that's the bottom will be K minus 3 over K3, and that will be Ki. Okay? Now, that's only part 1. I still have this E which I want to get rid of. So, we'll have K1 E into S equals K minus 1 into ES. So that connects my E to ES. So that will eliminate every variable except the ones we want, which are the Ki terms, the I and the S, and the ES in that sense. So let's make E the subject. E into S equals to Km prime times ES. Okay, so we bring the S to the bottom. E equals to Km prime times ES over S. So let's substitute this back into here, and then we'll get what we need. So we have a I over K into I, K over I, and E, which we'll just write all this here, KMES over S. Now we have this, we can substitute this back into this messy lot here, and then we'll get the following. So we'll have I over Ki, Km prime, and ES over S, okay, times Ki over I, concentration I plus 1, plus S over Km prime, plus ES, of course. And now, before we factorize ES out, let's simplify this lot over here. So I have an I and S at the I on top, S at the bottom, and Km prime over Ki. Okay. Then you have ES. So we have Ki over I plus 1 plus concentration of S over Km prime close plus Es. So I just want to make it a bit easier for us to see. Okay, so let's multiply this into the first term here. Multiply this into the first term, we'll just get this will cancel this out, and this will cancel this out. So we will just have these two terms remaining. Km prime over S. Okay. The one is rather simple. So I'll just copy everything down. And the last one, cancel the S, cancel the Km, you have I over Ki. So I over Ki, and we'll close it up, and we'll just have our Es plus Es. Now we can make Es our subject, and we'll just factorize Es out, and we'll bring the whole thing over. Now I'm going to do that in one step. So just watch. So Es equals to E naught. So I have 1 plus whatever this is here. So I have 1 plus Km prime over S plus I over S Km prime over Ki plus I over Ki. And now we have an expression for Es only in E naught, S, and I. And of course the equilibrium constants, Km prime and Ki. Well, let's bring this back to our V term. Let's bring this back into our initial equation, which will be this. Equals to K2 into Es. And let's have that Es replaced with something we already just did. So it's E naught over 1 plus Km prime over the S plus I over S Km prime over Ki plus the last one I over Ki. Now it's almost what we are used to, so let's just do the same step again to get our standard Michaelis-Menten form. So let's multiply S to the bottom and the top, and this K2 times E naught, we just call it the Vmax. So we have the Vmax again into S, so we have an S at the bottom plus Km prime plus I Km prime over Ki plus I into S over Ki. No problem there, right? So now we have this messy lot over here. Okay. Now what we're gonna do about this messy lot? Well, just wait till the next video to find out. We have reached about 14 minutes now. So let's cut the video for now, and let's move on in the next video. I'll see you in the next video. Bye.